Hello, everyone. Today I want to talk about graph-on-relational engines. Now, in the last 18 months, free cloud hyperscalers ship graph-on-relational, so did two major database vendors and a growing list of startups and open source projects. And what started off as an ambitious bet 3 years ago with PuppyGraph now feels like a category of its own, a new category in databases, one that challenges the very idea of a graph database. Today, I'm going to map this category, walk you through the architectural choices, kind of give you a simple decision tree if you're interested in graph workloads. So what's actually happening with these engines? Graph on relational basically means running graph queries against data that already lives in a relational database. So that means no copying, no ETL. A few years ago, if you wanted to do a graph workload, you would need a separate engine that you copy your data to or that you bring your data into. Now, today, depending on which corner of the graph on relational engine map you sit in, you can potentially run your graph queries against your existing data with no new infrastructure. And that's the story of graph relational engines. Now, before we go deeper, two things it's not. Right? The first one is these are not native graph databases. If you look at Neo4j, FalcorDB, Amazon Neptune, they all own their storage. Your graph queries map directly to pointer chases. Graph on relational does not have that. It reads from someone else's row and column storage, and so it kind of pays for that mismatch to the extent. It's also not a multimodal database, right? If you think about Cosmos DB or SurrealDB or OrangoDB, these store data themselves in multiple physical models. With graph on relational, the engine doesn't own the data directly. So in short, you could think of multimodal as a sort of graph and relational technology, which is not the same thing as graph on relational. Now, inside graph on relational, I would say there's two distinct architectures emerging. And the first style is a layered separate engine. It's a graph compute engine that sits in front of the relational source. It translates graph queries into SQL against that source. So PuppyGraph, for instance, lives here. So do memGQL on top or Prometheux. Selling points, it's flexible, language independent, no ETL still, which is very much what graph-on-relational does. But the catch, of course, is that you're going to have another system to deploy and maintain. But in my mind, it's the true-to-form graph-on-relational. The second style that we're seeing emerge is graph queries that are native to the relational engine. So think about Oracle Graph, SQL PGQ, Spanner Graph, BigQuery Graph, or Fabric Graph. It's graph pattern matching that lives inside the relational engine. And the selling point is really simple. There's no new infrastructure there. You're running it directly on one you already have, a very tight integration, and potentially some language familiarity for SQL teams if you're using technologies that are going to use SQL 2023. The catch, of course, is that you're kind of bound to the host engine, meaning that if you want to query across other relational data sources, you might be slightly stuck. So these two styles, in my mind, kind of deserve different labels. Layered ones, like I said, kind of a true graph on relational structure. An engine, I would kind of qualify more accurately as graph in relational. And just remember that because we're going to come back to it at the end. So with all of this, PuppyGraph really is the one that popularized this category. The pattern itself of graph on relational is actually kind of older. OBDA on the RDF side has done graph over relational for over a decade, and we'll come back to that. But PuppyGraph is really the first to have brought it to the label property graph world with serious engineering. It brought Gremlin and Cypher as first-class query languages with a clean schema mapping to your relational data sources, and very importantly, a lot of relational sources supported, meaning that you could query data across, Snowflake and Databricks and Postgres, etc., all within the same engine, potentially joining these together. And there's some limits, of course, here that's worth pointing out, and it might be that PuppyGraph, for instance, is better suited to analytics, OLAP style transactions, trying out OLTP. PuppyGraph being a read-only engine, it kind of makes sense. If you're looking at super large scale deep traversals over very large amounts of data, you might still find that a native graph store does it slightly better. But for analytical workloads where your data is already all over your relational tables, this is a super strong fit. The biggest thing on the SQL 2023 side of thing, which is the sort of in-engine side of things, is SQL 2023, which is a standards document that introduced SQL PGQ, which is basically property graph queries within the SQL language itself. It's a way to express both a schema against your tables as well as graph pattern matching expression directly within the SQL language. So in that space, Oracle Database 23 AI was the first commercial database to ship, I guess, a mature to the standard SQL PGK implementation. Oracle being, of course, the one that's kind of responsible for the design and implementation of that standard in the first place. And that's something that, for instance, we've added support for in G.V via the SQL 2023 language surface. Postgres 19 is coming soon, targeted late 2026, with that same SQL 2023 slash SQL PGQ support. Postgres, in Postgres 19 at least, will first transform the SQL PGQ patterns into recursive CTEs. Definitely convenient, but it's not going to be optimal for deep traversals. And those are conversations that some of the Postgres developers have been having publicly and that you can find out about. We've also got Kinetica that has added SQL PGKey support this year, and we've also got a really cool little community extension to DuckDB called DuckPGQ that did the same thing of adding this SQL 2023 support to DuckDB. It's somewhat active, but it's kind of research based. So don't expect it to be progressing too fast at this point, but there's a future where it could potentially, for instance, become an official DuckDB extension. Who knows? At which point it would really, really bring the technology forward within the DuckDB environment. Now, as I've mentioned, there's 3 cloud platforms that have shipped graph-on-relational in the last 18 months, and all 3 kind of made a similar or same language bet. So the first one, I think probably the most notable one, is Google Cloud Spanner Graph. They went general availability in January 2025. It's graph alongside relational, search, and AI in one engine. Google Cloud Spanner being very much a sort of multimodal kind of technology. And this is where things can get confusing, of course, because Spanner is multimodal, but the way they implement graph is very much graph on relational. It's not a separate store because it's executed on top of existing relational tables. This year, as of just April, I believe, BigQuery also released BigQuery Graph in public preview. It's a very, very similar technology to Spanner Graph. It uses the exact same unified Google SQL language, which provides GQL provisions, graph query language provisions within the language to perform graph operations. And it's essentially, if you think of Spanner as an OLTP database, which it is, BigQuery is the OLAP equivalent of it. This is a warehouse scale version. We've also got a Microsoft Fabric Graph that's in public preview with general availability expected for likely 2026. Now, all 3 of those, as I mentioned, chose ISO GQL, and that's not the same as SQL 2023. GQL is kind of closer to Cypher than to SQL, and it really treats graph as a first-class workload rather than a feature kind of stapled onto SQL. I think BigQuery Graph kind of proves the pattern works at a very large analytical scale. Some early kind of documentation and public conferences that have discussed it show some really interesting results on that. So we've covered a lot of the label property graph side of things, but we've kind of briefly mentioned a little bit about RDF. And so there's kind of a different side to graph-on-relational that's also worth talking about, which is the sort of what we'd call the semantic side of the field. And those are the ones I've actually done graph-on-relational for the longest. There's kind of 2 positions, I think, that are worth distinguishing. The first one is kind of pure RDF and OBE, and it's technologies like OnTop, which is an academically originated technology from the Free University of Bolzano. It basically translates Sparkle queries into SQL via R2RML mappings. And actually, OnTopic, which is the company behind OnTop, was recently acquired by Digital Science, actually, as of just March this year, with AI reasoning in the framing. It's kind of a strong signal in my mind that virtual knowledge graphs have a lot of potential and could potentially be going mainstream as well. The second one I want to talk about, and it's a technology that's trying to break from the graph database paradigm entirely, is Prometheux. It's an ontology engine that functions over arbitrary data sources and that uses its own proprietary query language called Vadalog. It's of the Datalog family, and it's capable of expressing both SQL and Cypher, but within that language. There's also some recent entrants that I think are worth naming in the space, and it kind of shows that it's something that's still rapidly evolving. And if we only start seeing those come up in the last 18 months, and chances are we're going to see a lot more of those. One of them is something called PuppyGraph, and that's super, super recent. I think that just came out 2 weeks ago at time of recording, and it's actually just in pre-alpha, but it's a Postgres extension that allows doing graph queries that are exposed as plain SQL functions against your relational tables. It kind of shares some similarities in a sense to something like Apache AG. A really big difference here is that this is specifically optimized for graph workloads with a lot of stuff going on in the background, such as like creating CSR tables, etc., that just really optimize on traversals. Whereas something like Apache AG, whilst it gives you graph capabilities within Postgres, is first of all not on top of your existing relational data, but it's also not massively optimized for graph workloads. It just makes it a lot more convenient. And the other one is memGQL from the memgraph team, memgraph being the in-memory graph database. Very similar to Neo4j, but with an in-memory engine rather than on disk. It's again, federated GQL engine, and it sits on top of a wide variety of relational sources. Again, that's only been released, I believe, 3 weeks ago at time of recording. And what it does is it translates the GQL queries that you submit to it into the native language of whatever backend holds your data. The interesting part there is that memgraph actually does that over relational sources, but actually also over pre-existing graph sources. And so now we've kind of covered like a lot of these things. Let's just kind of talk about where that leaves you. Like, let's just do a quick decision tree. So I'm going to propose five buckets of decision here. Right. Let's number one, data lives in SQL, and you want graph without new infrastructure. Graph-on-relational is a pretty good fit, provided that you are already on that technology that supports it. Worth pointing out, SQL 2023 being a standard. If the database that you're on right now does not support it, chances are it might well in the future do, and we're seeing that already with Postgres 19 bringing that support. And that's sort of what I would say, the maximum convenience option, right? You don't need any new infrastructure, you don't need to modify your data. It's there, you already have it, you configure it, and you're good to go. The second one is, say you need multiple distinct workload types on the same data, and that's where you might still just be wanting a multimodal database. Now, there's quite a few of them. Spanner, I think, is one that's really worth mentioning right now, because despite being graph-on-relational, it does allow you to kind of use all that convenience of Spanner and like the relational data model that they use to just deploy graph very quickly. But it's also worth pointing out that technologies like SerialDB or ArcDB and ArangoDB do all that. There's also Azure Cosmos DB, which has the Gremlin API, but the Gremlin API has sort of faded away from their communication material, and it's not really one that is being actively worked on, at least from what we can see in public material that they publish. But I will say a small note here that Azure Cosmos DB remains to this day probably one of the easiest graph databases to deploy out there at like a very, very good like 5.9 SLA, globally replicated, etc., etc. And that's really just because Cosmos DB itself is such a convenient engine to deploy. And the third one, I think, is say you want the graph performance, but you don't want to copy the data. So you're not really wanting that native graph database, but you do want something. And this is where my true to form, as I've described it, graph-on-relational version fits best. And so you want to look, in this case, at things like PuppyGraph or memGQL. It's a graph engine that really owns the plan, and it just doesn't leave things simply to a SQL optimizer. The fourth one, of course, is, well, look, your data is just fundamentally connected. Graph thinking is just the critical path for you. Use a native graph database. This is what they exist for, and this is what you should be using if you need high performance at scale on data that is fundamentally graphy. And the fifth one that I want to address is semantic unification problems, or sort of AI reasoning over sparse sources. And I think in that case, what you really want, if you're not looking for traversals, community detection, that kind of graphy kind of workflows, you should be looking at solutions like Prometheux or OnTop. And as we kind of wrap up on all this, I think what's really new here is that we now have a bit of a middle ground. 5 years ago, there wasn't really one. You either had to, well, you really had to rather to pick a database that matched your workload. If you want to do graph, get a native graph database. Now we're seeing a slightly different landscape. And so what we've done is we've actually put together a more comprehensive landscape post that discusses some of those options in a bit more details. We're going to put the link in the description, so you should check it out. And with all that covered, all I have to say is if you're new to Graph, check out graph-on-relational engines, check out graph databases, see what the factors are in your decision making that's going to help you pick the right solution for you, and make sure to check out G.V. We're a graph database ID that's compatible with a lot of different graph database technologies, both native graph databases and graph-on-relational engine, and it will make your life considerably easier working with those technologies, particularly if you're looking for visualization capabilities as well as querying help, etc., etc. And that's it. Thank you.